Hello, in this video we're going to talk about the definitions of probability. For example, imagine that we have a sample of 10 jelly beans, 1 blue, 2 purple, 3 greens, and 4 red. From this set of 10, we are going to draw 1 jelly bean. So this is the experiment. Experiment is an attempt to produce a random phenomenon where we know what outcomes could happen, but not which particular value will happen. So when we join the jelly beans from a bag, we don't know if we join from one, we don't know what color we're going to pick. So this is called experiments because we don't know the outcome or the particular value will happen. Okay. Event is a collection of outcomes. Usually we will identify the event so that we can attach probability to them. Sample space is the connection of all possible outcome value. The connection of value in the sample space has a probability of 1. So finding the probability of an event is the number of outcomes in the event out of the total number of the possible outcome. The probability of an event is a number between 0 to 1 that reports the likelihood of the event occurrence. Remember that it should be between 0 and 1 if later when we're doing this add or multiplication probability, your result is greater than 1, that means you might did something wrong. Theoretical probability. If we draw a 10 jelly bean with replacement, what is the theoretical probability of a certain event? So this is based on the assumption that the outcome have an equal chance of occurrence. So that means when you flip in a coin, right, you got a head. So theoretically, you have 50% to get a head or tail. But that's theoretically. You have 50% of chance getting heads up when you flip a coin. So empirical probability. If we draw 10 jelly beans with replacement, what is the empirical probability of a certain event? So empirical probability is based on the observation of the experiments. So this one is based on the observation of the experiment. So that means if we flip in a coin and this time you get a heads up. So that means on theoretical probability, you have 50%, right? But based on our observation, we got 100%. We only flip it once and you got the heads up. So that means the empirical probability is you got 50%, you got 100% of getting a heads up. These two, you only flip the coin once. So, in another word, I can conclude that for theoretical probability, we're trying to find out what should happen. And the empirical probability is what did happen. Okay, law of large number. The long-run empirical probability of repeated independent event gets closer and closer to the true theoretical frequency as the number of trials increase. Usually in statistics, we consider number greater than the trials greater than 30. We will consider that is a large number. But in my class, I want it to be greater than 35. Disjoint, also referred as a mutually exclusive. This is when two events cannot occur at the same time. For example, join a jelly bean that is both blue and purple. That means you are joining one jelly beans. They can happen to be blue and purple at the same time. It can only be a blue jelly bean or a purple jelly bean. That means when they happen, it has to be mutually exclusive. Okay, independence. The result of one event does not change the probability of the next event. So independent means being independent means when you have one event occurred doesn't change the probability of the other event. For example, the probability that a fair coin shows a heads after being flipped is 50% or 1/2 that you're getting a heads up. What if we knew that day is Friday? Does this change the probability of getting the heads? No. So the probability of getting a heads given that it's Friday is still 1/2. So the result of flipping the coin and the day being Friday are independent events. So knowing it was Friday didn't change the probability of getting heads. So these two events is called independence. Okay, so that's it for the concept.